All right, I am getting started here with where I left off. There hasn't been really any progress on the OBJ from raw stuff or the object generator stuff that I was working on last week. I haven't really done anything off screen like I thought I might. So I'm pretty much good to go to just pick up where I left off, except that right this exact moment, I don't have the example working. So I'm gonna try to get it working again, and uh, then we'll jump into uh, making more iterations. I think probably we'll try to burn away the additional, like the half abstraction situation going on with how the render works. Um, Probably that's what I'll do. I might also try to come up with a new name again. I'm still not really sure how to name it, but let's just dig into it and start making progress. There's just sort of we just need to spend time with this and make it better and better for. Let's see. Um, okay, so there's main.obj, but why aren't we getting? Wait, that's not what I thought it was. I don't think this is testing what I thought it was. Um, okay, maybe I just don't have the right test setup. So why is this breaking? We have symbol pack. Yeah. So I guess. Oh, maybe symbol pack has been turned off or something. Okay, I see what happened. So I built a new object file generator and like rewriter system. I made a first pass on an object file rewrite library. Let's say that. And then I went and built OBJ from raw. Right. But I didn't rebuild symbol pack. Okay, so here's the first step. We've got the library. I think the library first pass is up and running and working. But the OBJ from raw utility is the only one I've replaced. I also have the symbol pack utility that does something a little bit different. What this is doing is it's ultimately going to become the symbol set Mark II meta program, right? So the idea is you've got symbol sets. If you do symbol sets the way I've been doing them, they work just fine, but they bloat your process's memory usage because they use separate um, sections in the executable for small bits of data, and each section is aligned to 4K. So each one's getting a full page allocated to itself, even though it's got like 500 bytes. So if you don't want that bloat, and also if you want to have all these data tables packed more closely, maybe for memory fetching reasons or something too, the thing you'd want is to have all of that in the data section, and that's all this is doing. Is it's going through. It's a test case. It's not the full utility, but the idea is it's going through and it's rewriting one section to have the name .data. What that means is when we link them together, all the data sections are going to get glued together into one section of the executable. Right? Object files can have duplicate names in their section table. Executables cannot, right? It's unique names only. So duplicate names and object files become glued together into a single name section, right? A single section with that same name in the executable. So all it takes to say don't allocate this separately is really to change its name back to .data. So the only reason we are giving it a separate name in the first place is to force the compiler to organize their memory layout contiguously relative to one another. Then we can just say, well, rename that section. We're not even rewriting the section table here. All we're doing is rewriting some of the names, right? Or I guess it's one of the names in the section table. And that one name goes to being .data, and then the linker does the rest of the work to make it so that there are no more extra bloat sections, right? That's what it does, but I haven't implemented it since I deprecated the old way of doing things and built the new one, right? Over here in OBJ from raw, I did start using the PEGen OBJ. So this is the real thing, right? This was the sketch of the idea that didn't exist at the time. This is the real version. And so in theory, I should be able to do this. But SymbolPack needs the ability to parse, and OBJ from raw doesn't. And that's why it's possible to excuse me. That's why it's possible to implement OBJ from raw and not the SymbolPack. Got it. Okay. So we can't actually do this yet. What we need to be doing is building the library up to the point where it could do this, which means getting the parser part working so we can load. We haven't actually built. So a little review on how the library works. It defines basically this data structure. PEGen OBJ is what it's called right now. Probably renaming it is going to be one of the goals for this. I want some kind of name that I like, but right. So the thing that's missing is that right now, this is not implemented. When I will have an OBJ file, I want to be able to construct the data structure from that data, but I don't actually have that. This is just blank. Right, it's not even implemented. So that's one of the frontiers on which to iterate. Then there's all the stuff to burning off the intermediate abstraction. So what that means is before I wrote this rewriter back in the day, like almost a year ago, I wrote a PE generator that just generates a PE from scratch, right? A PE is an executable file, portable executable file on the Windows operating. So this is what I've got for actually generating the file. It's a lot of code, right? Now let's see. About 50 lines. About 50 lines of it. Wait, no, that's not right. I thought this was a different file. Never mind. It looks like where we were at, it took about 1,600 lines of code to to be able to generate one of these. So it might be a while to fully digest that and combine it with the other one. But I think that's roughly what needs to happen. This is all the knowledge we have about how to generate one of these files. And so far, in the new version, all I've done is call to this old version, which is much more verbose and complex, maybe rightfully so, but this new API feels more appropriate to actually create an abstraction layer too. Since it incorporates the ideas of editability, so the data structure is not just write only, but it's readable and writable. That's kind of the ambition of this one, and I think that that's the appropriate ambition for data structure right now. So my options are, I can work on it by doing this part where I start burning away the abstraction, or I can work on it by working on the parser. If I work on the part where I burn away the abstraction, I'll also hit some of these to-dos that make it a little bit less than fully accurate right now, because my generation is limited by what I could figure out on a first pass over the intermediate API. And now either the intermediate API is missing important levers for generating what I need to generate, or the intermediate API has it and I just couldn't find it. But either way, this code has been a little bit wrong since last week. So maybe we could try to track that down, but we won't really have a test case for that until we have file loading. So I don't know, it's a little chicken and egg. I think we might want to start on the file loading and then tick-tock back and forth between them over time a little bit. There are some other to-dos too, like cleaning up the API stuff. We don't have the ability to really insert data. A limitation on how useful, like we can insert one block of data to make a data section, but if you want to sort of stream data out or take a data section that exists and rearrange it or modify it, we don't really have anything to get you there. It's pretty deconstructing and reconstructing that, but we could definitely add in helpers lesson. Okay, so I gotta pick. I could also think about the name. Gotta think of a name. That's just what's gonna bug me. Let me. I don't know if this source is actually what. One way that this sometimes works out for me is so concepts related to this: generating an object file, rewrite an object file, parse an object file. Um, 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 hmm. Um, meta object. I'm gonna take a quick 5-minute break and keep thinking about this. Okay, be right back. Okay, okay. Gabriel Compute, quick question. Forcoder uses FreeType. Yeah, with FreeType. I like Live FreeType because it's less work. Once you get it working in one spot, it's portable. But it's also, I like it over STB FreeType because it's just, you can't get everything you need out of STB FreeType to do like full multilingual font stuff very nicely. And I don't know that I ever got the rendering to look as good as STB. So as much as I love all the other STB libraries, I've never quite been able to switch to it over FreeType itself. The worst thing about FreeType is that it's huge, and so what I do is I go and manhandle the build and specifically craft a like the build takes about a day, but I craft one that's just for my project. Like, only support TTF, drop everything else. Only support, one or two of the rasterizers, one or two of the formats. Um, gets the build size and the build times down a lot if you do. Okay, back to this vocoder, naming it. I kind of feel like this thing needs one of those quirky names, you know, because there's two different layers. There's in concept what it provides, but then there's like this specific one. You know, there's going to be lots of variant ways to kind of design something like this, and so just like often I just name a thing like base or graphics. You know, its name is the problem that the thing is solving. But for something like this, you need a name. Like you need a proper name, a proper noun name, because there's just so many variables to how you do it that you could easily end up in situations where you want two different kinds of parsers. It can't just be called PE parser generator because there's a lot of assumptions about what kind of parsing is happening. I kind of like the name Tinker. Yeah, I think this is on the right. This is at least in the right direction. Um, Object Tinker, Binary Tinker, Bit Tinker. I think I like the name Tinker because it's close to the name Linker, and it also is how working with object files feels. It feels like you are tinkering with the object file, right? It is not. It is not something that you do. Um, it's not something that you do fast and furiously. It's something that you do carefully because you tinker with it and test it a little bit as you go. Um, then you compile, you tinker, and link. Object tinker. Binary tinker. Bit tinker. Unit tinker. Just tinker. Meta tinker. You can always throw the name meta on something and it's not a thing. All my names end up sounding so similar. The last time I had a name I liked, it was Splink, and almost there again. I'm gonna call it Tinker. I don't think I like anything else. So the idea here is then I'd go like cough.h tinker tinker cough.h tinker cough.c. Later we can get an elf object, right? Go to macho. I forget if this one is separate in objects and then later we might also get a PE elf image macho image. And then we might have things like tinkered data structures that are shared. We might have things like an abstraction layer that tries to abstract all of them. Maybe sometimes that's too much when you start thinking about stuff like that, but sometimes it's a good idea. If we go that far, then we are right at the precipice of being able to then design our own object file format, right? Hey, Phoenix. Okay, so I think that's going to be the name, and we're going to start with a renaming pass to officially adopt this as a ongoing project and get it organized in a way that I like. Where does this file live? Gen, I assume. Yeah. Okay. We're gonna close ForCoder, even though it takes a few minutes to reopen it every time. Because I pull up projects or code base. Binary gen is going to become Tinker. Are you holding this open? Who's holding this open? Is it you? I'm not sure. It must be one of the ForCoder. Or maybe the rad debug. Let's just start with this Tinker. There we go. If I were to redo ForCoder, what things would I do differently? Okay, it's a great question. So for a long time, my goal with ForCoder was to make C++ specific code intelligence, and I ended up scrapping that piece. It's not entirely missing from ForCoder, but for the most part, it's everything I did in ForCoder could have been language generic. And I think at the time, what I was pursuing is still something I believe in. I just don't think that that route is good. So the idea was to expect higher level features out of the editor. Right? I expect the editor to operate at a level of richness with respect to the semantic and syntactic structures of the program that require basically parsing and partial compilation of the code all the time. And so the thinking was that it's not going to make sense to do this as an editor for multiple languages because it's going to be so much work to do it for one specific language. But it turns out even if you make that call and make it specific, you can't get as far as you might want. Even if you have a full compiler, right, at your disposal, there are just built-in problems with doing this in C++, and that's mainly to do with things like the number of things in a C++ compilation that are dependent on factors that you don't have in just the files, right? So you have all these text files. They're supposed to form a program, but some of the information about how they form a program is in a build script somewhere, right? It's in a make script, or it's in a batch, or in a shell script, or something somewhere that says here are some defines that you need to set. Here are some changes to compilation rules. Here are the things that I want you to be able to include, right? If you don't have all of that information, then you don't actually know how to recreate the structures of the code. But there are other issues too, like the amount of distance that there is between a textual presentation of code and the semantics behind it. Even in a language that was designed to not have ambiguity, so that whenever you're looking at a piece of text, like if I have a text file, I can always interpret it. Say that was your language. It was designed in such a way that any file in isolation, you can interpret it meaningfully. And you try to design it that way so that you can write an editor that can just parse the text it's reading or it's editing and make the rich experience out of that. Um, I think that the number of problems between things like formatting and style conventions and the issue of organizing the codes, when a lot of the modifications you would want to do at a high level include things like inserting a new function. Well, where does that go? How do you specify that? These are all things that a text editor has never had in them before, and at some point you end up needing a text editor to be a part of this story anyways. Like you end up needing the you end up needing all the things you need in a text editor to still work like a text editor in addition to these new things, and that it turns out that I just think that's over constrained. Right, the limit at what you could do in your imagination with a code intelligent system can't be reached in a text editor because that over constrains in a different direction. So, if I was going to build a text editor, to get back to your original question, if I was going to build a text editor, I wouldn't bother with the code intelligence thing. Instead, I would try to think of as many things as I could do to make the interface for flying through that text better, right? I might say, for instance, let's focus on things like being able to bookmark spots in various files. Let's think about how to multiplex multiple projects. I want to be able to specify projects and have workflows associated with each of them and have them loaded in and connected into the environment in different ways. I would focus entirely on things like the workflow, discoverability, maybe an indexing data structure like a tree sitter or something that lets you have a scan of all the symbols is a good idea, but that should be done in such a way that it can be language generic. As long as you're going to be in a text file system, because I don't think you can do any better. It turns out you can't. The higher level stuff that you think you can do by specializing isn't worth it. It's not really available. Um, so yeah, that's the main thing I would do. Is I would focus on. I would also focus on like reloadable plugin system. The four coder custom layer is a monolith. You just have one DLL that specifies the customizations. So if you want to plug pieces together, you have to build your DLL yourself. You can't just download a binary of a plugin and say start running it, and then you can't. You also can't say like, hey, run this in development mode and let me unload it and reload it and do whatever, patch the plugins. I would make all of that much stronger. And Phoenix, to answer your second question, yes, the thing I'm still looking for, the sort of thing that we did with the Dion experiment. I think the Dion experiment was also wrong-headed in a different direction, which was it was the idea of abandon text file, but instead of abandon text file and keep the structure of the ecosystem intact, with a replacement data structure, we were thinking throw the whole ecosystem design out, architect a new one from scratch, and I think that's a mistake too. But I don't. I think it's a little more subtle to see why it takes. I mean, a part of it is that that's been tried over and over and over again. And while text file, the data structure may not be ideal in every possible way, the behavior of that data structure with the programs around it is worth noting because that seems to be working. And so a new replacement data structure should have all the same interchange capacity. Anyway, so we managed to rename this Tinker. This is the old stuff that's going to evaporate away. This is a test case file for this. This is the actual Tinker implementation. So this is the one I'm going to pull out. This is tinkercoff.c and tinkercoff.h. Now that I have that, I should be able to set up a four-coder here and get everything building again. No folder, I think. We'll leave those there. And then this just needs to go live in Tinker. Which, I already busted it. Sausage first or sausage fist? Yes, exactly. I originally was attempting to build code editing that knows you're editing code and not just text, and ultimately decided that I wasn't really succeeding at that. But that what I was succeeding at was building this customization link for a text editor that worked in a different way than you had access to in other editors or other other editors were customized scripting language, and this was just a pretty straightforward, bare bones native API, like see linkable API for customization. So that took off, and that's what I focused on. But yeah, I changed it because exactly I was learning more and more that there were theoretical problems with doing what I was trying to do that ran a little deeper than I had anticipated when I excitedly got into the project. Right? I mean, it's not because in concept the ideas make sense. You're gonna compile the code part of the way, analyze and modify the data structure in its intermediate format instead of in its text format, right? There's some data structure that is deeper in the pipeline than the text file at which you want to be able to specify your edit. That makes sense conceptually, but practically the text file is still there, and you still need to render that back out into text. And that fact that it's a round trip, it's not just generate some intermediate, modify the intermediate, and then generate your executable, but it's got to be generate an intermediate, modify the intermediate, and then generate text in such a way that the new text satisfies two constraints. If you compile it again, you get back to the modified intermediate. But when you look at it as a human, it looks like something you can still understand and type with. Like the generated text is what you would have typed. That pair of constraints is actually really hard. And then there are a bunch of like just other issues with C++ in particular. And there are other issues, like just because you can modify an intermediate in a certain way doesn't mean that you can actually render that out. There are so many issues of like what intermediates represent valid programs, not from that point forward, but that there's actually some text that does generate this intermediate isn't always a given. And I mean, you could definitely design a language with a textual front end that is meant to be used this way, but I think that the other issues, like the deeper issue here, is always comes down to the fact that there's so much extra effort in the design and in keeping the forward and backward versions working and making sure that they are simultaneously accurate to the compilation meaning but also useful to the human interface. And all of that comes down to the fact that the text isn't really a choice of interface that aligns this data structure to both needs simultaneously. Um, okay, so where did that leave? I was in the middle of renaming stuff. Probably it's still broke. Tinker, cough.c, now tinker cough.h. I just want to throw the include in here. It's a temporary dependency. We want to get off of it. Start with this being just acknowledged. Right inside the thinker file. That way, yeah, so this one's going to end up needing to get rewritten, but it's going to be something like tinker cough. That's not lovely, but it's a right step for now. We'll start saying that when you want to do this kind of tinker work, you're just gonna get it all in a one-stop shop now. We no longer have to include all these sub pieces manually. Because they'll be included by the tinker directly for now. Later on, we'll clean that up even further. Okay. Now, the other issue at hand here is I don't have a test case up and running right now. Let's go over to the side project. And we'll just make a build graphics.bat, same way we did with build main. That way I should be able to stand right here and do build graphics.bat. Build graphics sh. This does run OBJ from raw, therefore it's testing OBJ from raw. Okay. So I should be able to do bin/build graphics.bat. That links, and then rpg.graphics graphics.exe. But I actually have to run that from the data folder. There we go. Okay. Cool. When Windows 10 goes end of life, where will I don't know. I haven't upgraded to Windows 11 on anything yet, so I've been getting used to it. I still don't really know how to live life from Linux days. So probably I'll go to Windows 11 if I absolutely have to. I guess I'm also gonna probably, for as long as it's not gonna be the first issue. I'll have to look at consequences. Yeah, yeah. I know Windows 11 is not great. I'm not really sure. I'm maybe it will be the deciding factor that it's time to more and more. But I haven't really been pushed. Okay, so renamed everything. I'm going to save that first. Okay, let's see. So now I want to go through the Tinker code itself and do the renaming inside the code. The idea here is that Tinker will become the name of the whole library and project. TNK being a nice little namespace. Start with the namespace shift. Okay, now let's double check that I like these type names. Tinker get a node. Get a node. Set block. Action field. Yeah, so okay, let's do the namespace right here real quick. Tinker. So that might be risky because there are two different things here. Let me do this again more carefully. Yeah, all of those have to keep that. Okay, so there, it's fine. Here, it gets a little more complicated. Okay, this data node kind becomes cough node kind. Data nodes look like this. Cool. Okay. Just to be sure. Still building. Still running. Okay. Hey, welcome people. Let's see here. So that's part of the renaming work, but digging a little deep. I think these are going to end up being generic, but then that means all of this is actually cough specific. I think these are going to end up living in a data structure file along with the set block and data nodes. But I don't want to push into that until I have a second object file type to support. Looks good. Okay. That should make that a little smoother. Right. Okay. Is that all the renaming I want to do? The cough or cough specific node and then H9 maps one structs and then cough specific. Okay. Let's reorganize this part. Okay. The only issue is I can't separate them from cough yet because they're still all totally tied in with this particular context. There may also be issues with no, I guess not. Yeah, if we were to go separate out this and this, this forms the reusable part of the context that provides the data nodes and the set blocks. These are cough specific. Once that's separated, this shouldn't need to be namespace with the cough stuff. But for now, maybe I just keep it the way it is. Good. All right, so I think that's another commit. Now, I'm feeling a lot more grounded on what we're doing here. I know where things are at and what needs to happen. I think the next big thing is to either start loading files, or start picking apart the old generator and incorporating it into this one. But I think I want to do this one. It's just, I got to figure out how I want to test it. So my plan is maybe we will focus on another one of these utilities that can be revisited now. Binary util right now also includes PE table, which doesn't need rewriting, it just needs the reading. But if we're gonna be able to load a tinkerconf data structure from a file, then we can use that as the parser. It might be a little more heavyweight than the parser we have now, right? It might be doing a little bit more data structure constructing effort than it needs to for this use case, but I'd rather have all my utilities go through a bottleneck in a sense. Like, I'd rather have them all depending on the same thing so that it's tested, if that means minimal loss of, you know, efficiency can still be achieved. Right? Or to put it another way, if I can still make it relatively efficient on this one, even if it's not top efficiency, it'll mean I don't have to worry about maintaining a parser that is direct for PE table and a parser that is structured for rewriter uses, and keeping bugs from and both of them in sync. Rather, I take the hit and just build one of these, do one of these Tinker data structures, even for a case where I'm not intending to modify the file or generate a new one. So what's cool about that is that means I'd have to rewrite this to work on top of that data structure. Now let's see where I'm at. I'm feeling hungry. It's an hour and a half since I started. I think now is a good time. So I'm gonna say we didn't really do anything major yet. It was just kind of structuring and coming up with that name to separate this out and put it on a more solid footing of how things are getting organized. But I think it did in fact pay off to do a naming pass. I pulled these out better, and it's clear to me now where there are reusable components and where there are call specific things in all of this. And I don't have a bunch of stuff that is almost named the same thing. The only thing left to do is the old generator stuff is still sitting in there, being overloaded on that, and then this block thing is a dependency of generator, and this is a dependency of all of the generator and stuff in here. And so figuring out how I want to organize that to make this into a reusable library is still going to be an issue. But now that I've got a name for it, I feel a little bit better making judgment calls about which things are going to be officially part of the Tinker library or not. And I might end up saying that this library should be completely independent of my code base. Seems like a direction I would probably go in with something like this. And in which case, all of this will need to be dependent of my code base too. And so it'll start all becoming part of the Tinker namespace. And now I know that, so it's a little bit more organized. But there's a judgment call there where I also want, like, at least the self-image stuff is outside of Tinker, and that requires the format part. So there might be binary format and then Tinker on top of that layer. You might need 2 layers instead of 1. But I think here's my idea. I'm gonna cut this stream here. I'm gonna get myself lunch, take an hour or so, maybe 2 to clear my head. When I come back, the to-do for today is to get the PE table utility rewritten onto the Tinker API. We're gonna rewrite this onto the Tinker API, and then then we can implement the Tinker load from file path, right? Okay. I think with that, I'm gonna sign off for now, and I'll be back again, like I said, in 1 or 2 hours to pick up right here. All right? I'll see y'all later.